All right, so now we're going to use direct comparison test. So this is a pretty useful test. It's probably one of the harder tests to use because you have to choose what you're comparing against. The whole idea, though, for a direct comparison test is I'm going to compare it to a series, and I want to demonstrate that, like, if I have a larger series that converges, then the smaller series must converge. Or if I have a smaller series that diverges, then the larger series must diverge. Okay? So there's a couple of things. One, I need to know whether I have an inkling as to whether it converges or not, and then I got to try a few things. So in general, I think this will converge because this is very similar to 1 over n squared. And by the p-series test, this one converges, right? So I kind of want to compare it to this series somehow. And here's where you would have to say, like, well, I want to compare the series n squared over 1 over n squared plus 3n minus 5. Now, in general, starting at like n equals 2, this denominator is bigger than this denominator, right? Because if I plug in 2, this is like 1/4, and this is going to be 1 over 4 plus 6 minus 1 is 1/5. So 1/4 is bigger than 1/5 because 5 is bigger than 4, right? So in general, we would say that this sequence this is bigger. Except for n equals 1, but you can ignore the first term. Just that eventually, as n increases, this series is definitely bigger. Okay. But because I know this one converges, that means the sum, remember what converges means, is it means that if I add the infinite number of terms of this, it gives me a finite value. And because these are smaller, right, if I add up an infinite number of smaller values, that must converge. How could that go to infinity? So this one also converges. And that's how you use this direct comparison test. Okay? It wouldn't work if it were the other direction. Like if I had this arrow facing the other way, a smaller sequence converging doesn't necessarily guarantee that a bigger series converges. Okay? So same with this ln n over n. I want to maybe compare to 1 over n. And this is why this test is kind of hard. You gotta have to like gauge it a little bit. In general, I know this one diverges because this is by the p-series test. This one diverges, and so how does this compare? Well, this has an ln of n, and ln of n is definitely bigger than 1 for values bigger than 1. Like starting at 2, this is definitely bigger. Okay, so then we can say that, starting at like around 3 or so. So I know that this one is bigger. Well, because this one diverges, and these numbers are bigger than all of these numbers, if I add up these numbers too, this one must also diverge. Okay. So this one you would say diverges. You need to make an argument when you kind of explain these out. This one diverges by harmonic. This is because you could call this is the harmonic series or p-series test. Okay. So how about this 1 over square root of n squared minus 1? Well, this looks kind of like again, you're looking kind of like at the dominant term a little bit. This looks like 1 over square root of n squared, which is equal to 1 over n. Actually, technically absolute value of n, but like n is always positive in this case. So we have 1 over n, and we want to see like, well, so the argument I'm going to make is, well, I know square root of n squared minus 1 is definitely smaller than square root of n squared, right? Because if I subtract 1 on the inside of the square root, that makes this smaller than this one automatically. Then when I do the reciprocal, I have to flip the sign like this. And that's because when I'm dividing by a smaller number, that makes it bigger, right? 1 over a smaller number is bigger than, when I divide by a smaller number, I get a larger value. And this is 1 over n. And again, I know this diverges by the harmonic series or the p-series test. This one, and because this one is bigger, this one must also diverge. The order definitely matters, the sign. The smaller series diverging lets you know a larger series will diverge, or a bigger series converging will let you know a smaller series converges. Okay, to get that. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.